All right, YouTube, we're back. It's Life After Calculus, Day 8. All right, so this is what we're going to do. This is my review sheet. Remember when I gave you, like, pre-tests? Before every test, it was like, I don't know if you recall, there were sort of odd questions, like 1 and 3, and then the test would be 2 and 4. Yeah, I have a whole PDF of review questions. That's what this is. And this is the first one from Unit 1. And we sort of skipped this because this was pre-calc stuff, but that's okay. I can talk about this at Malloy at Teachers Teaching with Technology, so there you go. So here's the first question. TBQ1. By the way, did you ever figure out what TBQ is? Textbook question. I have TBQs, I have TBSs, I have TBLs, all on sale on eBay. What? TBQ is a whole book of questions, pre-tests and tests. TBSs are a whole book of solutions, handwritten. And TBLs are all my videos and smart notes and stuff.
I'm a math teacher. Are you a math teacher? She's like the, are you 18 or older filter? No. Yes.
Wait, oh, you're trying to buy stuff on eBay? I have no sales in New York State. On purpose.
So we get it shipped to like our grandparents.
I have no sales from Romania either.
No, I would just, you could just
Nothing.
ship and then ship to you, right?
Yeah, I know.
Like IP bouncing.
Yes, exactly. All right, so listen up. Here we go. Here's the first question. Consider this piecewise defined function. It's linear. It's not. Okay? A function f is defined on the closed interval from -4 to 3 and has the graph shown above. Sketch the graph of y equals absolute f of x. Now, can you do this in your head? What's the absolute value of this going to look like? All the negative y values will become positive. So this, I guess this is a circle, will look like what? Let's say this is a semicircle of radius 1. So flip it up here, right? And then this piece of this line should end up here, right? So how do we get Sage to do this? First of all, how do we define a piecewise defined function in Sage? And then how do we graph the absolute value of it?
Addition.
Amazing. Well, yeah, but you could do this. You could say y1 is a plot of this line from -4 to -2, whatever it is, right? Y2 or F2 could be this line. F3 could be this line. F4 could be this line. And you can plot F1, F2, F3, F4. Okay. But then how do you take the absolute value of the whole thing in one swell foo? You can't. Well, you could. But what I'm thinking is, can I make one function that represents this whole mess? And then I can just absolute value it. All right, let's see. All right, so let's get into Sage. I didn't log in yet. I do screencasting. All right, the new worksheet is, okay, Life After Calculus, so 8, Unit 1. It's pre-calculus. And the date, right? Wait, what do we usually put your name and the date, right? So what is it today? Is it today the 30th already? Oh, my God.
After today, we only have 6 days left. Let's go.
All right, so this is number 1. All right, and this is literally number 1 on here. Okay, that's what I'm doing. Okay, so first we have to figure out how to do piecewise defined functions, and that's where you come in. Google it. Google piecewise Sage. I'd be serious.
Can't you just piecewise Sage?
Yeah, I forget the syntax.
Can't you just plot 2 things and then say, like, and the 2?
Yeah, I know, but I don't want to do it that way. I want to make it one function that I can absolute value with the whole thing in one step, right? All right, so if I go and I do, I don't know, on Google, let's say piecewise functions in Sage. How about that? Okay, reference manual version 5.9. Okay, it should be that there, right? I forget the syntax, so it's something like, oh, here you go.
So you said like F1 effects.
Right, so you define F1 as whatever it is, F2 whatever it is, and then F is piecewise of a combination. Now, what the heck is this? Okay, so it tells you where to graph F1, and then where to graph F2. So it's a list of lists. Do you see this bracket, square bracket thing? This is a data structure in Python called a list. So you have a list of functions. Here's the first function. Here's the second function. And the function itself is a list of the domain and the function itself. Okay, so I think we can do this. Let's do it. All right, so let's say f1 of x equals. Now look at the graph. Whoops, not that. What am I doing? How would you write this graph? This is a line of slope up 1 over 1, right? What's the y-intercept? If it goes up 1 over 1, up 1 over 1, up 1, it's 3, right? So isn't that just x plus 3 then, right? Okay, so f1 is x plus 3, but I'm only graphing it from -4. It says from -4 to 3 here, right, for the whole thing? So -4 to 2, -2, right? So let's see if we can graph that much. Where am I? All right, so this is x plus 3. But f is going to be piecewise of a list of a domain -4 to -2 of f1. Wait, is that the syntax? Let me look at the syntax again. Wow. Yeah, I think so. All right, so does that work at all? Let's do, let's see. How would we graph that? Plot f? Plot f. All right, so from -4 to -2, you got that. All right, that's sort of huge. All right, so just graphing that much, right? Okay, we're getting there. So what are you? Who's stuck? We only wrote 3 lines of code. Oh my God. All right, the syntax is weird because you're not used to lists, but one of the main constructs or data structures in Python is a list. So this is a list of functions which themselves are lists made up of a domain and a function. Okay, so who doesn't have a graph? Who's stuck? Let me know. We're good? Well, yeah? No, okay, all right, so
F1 and then we have F.
because f is going to be the whole thing, all pieces put together. F1 is going to be a line. F2 is going to be another line. F3 is going to be a circle, right? All right, so tell me the equation. Whoa. Give me the equation of this line now. What's the slope of this piece? -1. What's the y-intercept now? -1. Okay, so let's do that. So let's see. Let's make f2 what? -x minus 1? Okay. And then let's make another list, another list of, now it only goes from -2 to -1, I think, right? So in parentheses, -2 to -1, comma, f2. So far so good? That's what we wanted, right? That's all the code, 4 lines right there. Okay. I'll say this is like, I'm going to label this piecewise or something, I don't know. Is that how you spell piecewise? That looks weird. Okay. All right, so that's F2. So what's F3? Oh, God. Yeah, so isn't this x squared plus y squared equals 1? So y squared would be 1 minus x squared, and then square root it. But the principal root would be the top half. I want the bottom half. So negative square root of 1 minus x squared. No, by the way, if we did this day 1, I would be spending all day just explaining that. Right? You guys are so good at this. It's scary. Do you realize this is a rite of passage? You've got, right? Do you know what I'm saying? Negative rad 1 minus x squared? Yes? All right. Y squared minus 1?
Look on the top, it says y3 equals x squared minus 1. It's a parabola.
Oh, you think it's a parabola?
It says on the top, x squared minus 1.
Oh, it does say it. Oh, it is a parabola. Wait. That's interesting. Okay, it is. All right. Well, I mean, it doesn't have to be parabola necessarily. They didn't specify this. They just gave you the graph. They didn't specify it. I made that up when I graphed it. Notice, how did I graph it? When I wrote this, I don't know, 20 years ago, how did I graph this?
Wait, did you?
Where did this graph come from?
You use this really cool TI ability for. Wait, is that an 83 or anything like that?
That's probably an 83.
Yeah, if you use the 83, there's this really cool thing where it's 83 bases and
And basically dividing by 0, so it's undefined.
We're multiplying by 0.
Where you don't want. Okay. Yeah, but more to the point, I just cut and paste this straight from a TI-83. There's this program called TI Graph or TI Connect or something that you can hook up your graphing calculator to your computer and cut and paste anything that's on your calculator to a Word document or whatever you want to do. So that's how I used to do graphs. I don't do that anymore. That's old hat. So, all right, you want to make it a parabola? I just made it a parabola. They didn't give us that. I just made that. So you want to make it x squared minus 1 from negative 1 to 1? Okay, let's do that. Okay, go ahead, say it. Say it. Look back here. All right, so let's make it a parabola. I was thinking it was a circle. They didn't really specify that in the question. By the way, realize this is an actual free response question from an AP exam. I didn't make this up. They didn't give you the graph, though. This is pre-graphing calculators. They didn't give you the functions, though. All right, so let's say f of f3 is, what did you say, was x squared minus 1? Yep. Okay. It could have been a circle. I don't know. Nobody said.
How did I must have done something wrong, but now I have a non-function.
That's bad.
I literally don't have a function.
Well, then you your domain is wrong.
Yeah, that's what my domain is.
All right, so what goes here? You tell me what goes there.
Kind of awkward.
You got comma, brackets, parentheses, negative 1 to 1. Okay, and after the parentheses, comma f3. This isn't so bad. Not f2, no. All right. Now, when I wrote this Word document, I assumed it was a parabola, but from the drawing they gave originally, I think it might have been a circle. I don't know. But anyway, this is the code right here. Who's stuck?
Oh no, I am today.
All right, so Unit 1 is going to be I'm going to go over the pre-tests 1 and 3. Unit 2, I'm going to go over the pre-tests 5 and 7. Unit 3, I'm going to go over the pre-tests 9 and 11. That's what we're doing from now on, okay? All right, so I got one more piece left, right? What is this? Now, that is a circle, isn't it? Yeah. Now, that's a circle centered at 2, 0. So that's x minus 2 all squared plus y squared equals, I guess, a radius of 1 squared. So that would be 1 minus x minus 2 squared, square rooted, and principal root, yes? So let's do it. So let's make f4 of x equal to, what did I just say? The squirt of the quantity 1 minus the quantity x minus 2, was it? Minus 2, and that part is squared. And then I'm graphing that from 1 to 3? Okay. So, comma, list. Whoa. In the list, we have a domain. Domain is 1 to 3. And then after the domain, comma, F4. And that was just too easy. Now, does that really look like a circle? Not really. A circle of radius 1? What's wrong with this?
You have to make it a square.
I have to make it a square window. So to do that, I think I can do this. Comma, aspect ratio equal to 1. There you go. That's more squarish. A circle looks like a circle. A slope of 1 looks like a slope of 1. Right? Is that better? To answer the question, you don't have to do aspect ratio of 1, but it's nice.
Yeah.
Okay. All right, so now let's answer the question. Now that you got the function already, let's answer the question. What was the question? Graph the absolute value. All right, so let's go. So how about we go here? Plot. This is actually, this is 1A, right? So let's do that. This one, number 1A. Let's plot. Okay, you tell me. What are we going to plot? How do you think I'm going to do the absolute value? ABS of F. And I guess we should do the aspect ratio thing. Nope. Oh, boy, it doesn't like that.
Piecewise doesn't allow abs.
Oh, that's not good.
Each one individually.
Yeah, that's a problem. I didn't want to have to do that. All right, how about this? Is there an F.abs? Nope. I know, but I sort of didn't want to do that. I guess I could. All right, let's see. The only difference really is the negative branches, the negative y's, right? So I could absolute value those. Wait, is there a way around this? Hang on. There's got to be a way. Wait, what if I did, does it work with normal functions? What if I said absolute value of f1? Just that. Okay, that worked, because f1, right? F1 was this piece? Wait, that's not right. F1. Oh, it's not the right domain. Oh, that's weird because, all right, so let's do the right domain. What was the domain for F1? -2 to -1, right? So -2 to -1. The plot command, you just list x min, x max. Wait, I'm not happy.
That size is just a little bit off. No, it's -4.
It's -4.
Oh, -4. -4. What am I doing? You know, I know how to do this. Oh, now I'm happy. Okay, that's what absolute value should look like, right? It's not the okay. So it does it for f. It doesn't do for piecewise. Dang it! Ah.
Hey, you know what would have been a good idea?
Huh?
You know what would have been such a great idea? Is we made all those things and added them together in one plot, and I bet we could do an absolute value.
You think that would work? I didn't think that would work.
Mr. Garcia, why don't we just redefine the piecewise function except using the absolute values?
Yeah, I know we could do that. I was trying to avoid that, but I guess we have to do that. Yeah. Yeah, I know.
Wait, we could write a function that would change, we could write a function to apply to lists that would automatically make all the list values positive. That would be pretty useless.
Yeah. Okay. Negative.
And I would call it list abs.
It won't let me do this. Dang it. Why won't it? All right. So, all right. There's more than one way to skin a cat. Copy this whole freaking thing.
No, wait, Mr. Garcia, you don't need to copy the whole thing.
Well, just the ones that have. Yeah.
You need to copy the effing orange.
Yeah, I know. But I'm gonna pretend to do what I was gonna do. I'm gonna abs everybody. Yeah, really. Even if it's not negative, just in case. Who knows? All right. Just let Sage do the work. I don't even have to think about that. It's not that, you have a mouse. You can cut and paste. It's not a big deal. All right, so now I've redefined F1, F2, F3, F4, and therefore F.
You guys copied that one line.
Yeah, I know, yeah. All right, so anyway, is that what you expected to see?
Yes.
All right, so the negative branch here became positive y values. The negative branch here became positive y values. Okay, so that's a 1. Are you ready for a 2? Or 1, what am I saying? 1b. Well, yeah, I'm having a good day. 1b, can you sketch f of absolute x? Can you sketch f of absolute x?
Yes.
All right, so what do you do? Is anyone stuck at this point, by the way? Are we okay with this? Yeah, I'm going to cut and paste the original, which I already copied it. I'm going to put it here, number 1b. Put it here. But now where does the absolute go? Around the x's. So it's going to be abs of x. I want f of abs x. What? What happened, Derek? Graph which one? 1a? Okay, I'll be right there. Hang on, let me just finish this piece. All right, the absolute value of x before you change the sign. The absolute value of x before you square it.
Wait, can't we do abs around F1, F2, F3, and F4 in the line?
Oh, yeah. You probably could do that. Yeah. That's fine.
That seems like it would make
And then put the abs here. I just want to make sure I'm absolute valuing the x's, not the y's. Right? 1a was absolute value of the y's. 1b is absolute value of the x's. Okay. And is that sufficient?
Wait.
What? No, that's not what I wanted. Wait, no, this is not working.
Wait, why are you absolute valuing the x's? That won't make a function.
Well, because that's what it said.
What?
I'm taking the absolute value of the input. Yeah. See, that's a good question. Absolute value of the whole thing?
Wait, can you even put in f of x, f of absolute value of x into a piecewise? Yeah. Like, I don't think that turns out like this.
You know, okay. How about this? All right. How about this? Start over. Let's say, now what I want to do, all right, let's do this. How about we say f1 of x becomes f1 of abs x. That's what they want, right? Okay. So leave this the way it was, and then let's redefine it here. All right, this will be 2. This will be 3. This will be 4. This will be 2. This will be 3. This will be 4. It's still doing that. What is that? That's not right.
Maybe it is.
No, because, all right, think about it. If you change the sign of the y's, you reflect across the x-axis, right? What I'm effectively doing is I'm changing the sign of the x's. Isn't that reflection across the x-axis?
No, it's not changing all of that.
Yeah, only the negatives, right?
Does that mean that
So-
the left side of the graph will change?
All right, so when x is positive, we should do the same thing, right? When x is negative, that's the problem. The problem is the ranges. Because when x is positive, I'm just going to leave this alone. But when x is negative, I'm just going to reflect this. I'm going to reflect this over here. That's not that easy.
What I did in the
Did you get it to work?
what I did in the line for piecewise instead. This went down here.
Yeah, I don't want that there. I did that. I got that too. Yeah, that's not what I want. All right. So the problem is the domain has to change too. All right. So let's think about this.
Did you f3 absolute x from -1 to 0 and then f3 from 0 to 1?
Yeah. Okay. Going from f to the absolute value of f is easy because all we're doing is changing the signs of the y's. So that reflects across the x-axis automatically. This is not as obvious. I want to reflect across the y-axis, so my ranges are going to change. These ranges are messed up now. All right, so let's think. How about all right, I think what we need to do is not do this.
You do that stuff just spent typing?
Yeah, go away. I told you we're trying to figure out stuff. We're figuring out stuff. You're helping me out. All right. So the thing is that F3 and F4 are good. That much. F3 and 4 are fine. That's fine. What I want is this to reflect across here. So I really don't want to graph F1 and F2 anymore. Right? When x is negative, I'm going to change the sign and plot this stuff. Right? So f of -1 becomes f of 1. F of -2 becomes f of 2. F of -3 becomes f of 3. I'm reflecting this. I'm not graphing f1, f2 anymore. Yeah, so what I want to graph is, I still want to graph f3 and f4, but now on different domains. This is f3, right? So I want f3 from -1 to 0. Okay. And I want f4 from -4 to -1. F4 from -3 to -1. -3 to -1. No, whatever. What happened?
No, you can't have F4 because F4 is not a cert. It doesn't exist then.
Right, it's not defined. Right, so that's where the absolute value comes in. All right. So, okay, so I could do this, abs of x, and have the same thing. Right? I don't need it there, but I do need it here because the problem is I can't plug in a -x for the circle. It won't exist over there. The domain is wrong. So let's now plug in the absolute value of x here. This is the key here. We need the absolute value. There it is, but that's it. That's it. There it is. So the thing is that when you plug in -x's, if you absolute value them, become positive x's. So you're not graphing f1 and f2 anymore. You're graphing f3 and f4, but you're flipping it. Yeah, that's what it means to change the sign of the. Remember translation, dilation, rotation, reflection, geometric transformations, right? When you change the sign of the y, you reflect across the x-axis. When you change the sign of the x, you reflect across the y-axis. And when you add something to the y, you have a vertical shift. You add something to the x, you have a horizontal shift. Right? Remember that stuff? That's what this is. All right. So that's 1b. Hoi. This is just graphing. We didn't get to the calculus yet. They're going to get into a question about continuity and differentiability on these graphs. It's coming up. Who's stuck? All right. Huh? Because it's not defined. I'm reflecting this piece from 0 to 3. It's not defined beyond 3. So that's why. I don't think I can even do. Could I possibly do -4? What would happen? See, it's going to give you an error. That's all. It just doesn't exist. All right. Okay. So that's 1b. So we're taking forever just graphing. But eventually, look at the question. Wait. I keep on hitting the wrong thing. Look at the question. What's 1c? What happens if you just change the signs of all the x's? Okay. 1b, 1d. What happens if you translate a horizontal translation? What does x plus 1 do? Shift to the left, right? And then a dilation, make all the y values bigger. And then it's going to ask you stuff like, is it continuous? Is the first graph 1b, the first absolute value graph, is it continuous at 1? Well, let's see. Let's answer that. It's right. At 1, it's continuous, right? But is it differentiable? No. But they're asking for continuity, right? Now remember, listen. Remember the Cuban theorem. Is f of 1 defined? Yes. Is the limit at 1, does the limit at 1 exist? Is it the same as f of 1? Okay, so there it is. That's the answer to that question. Right? Is the absolute value of the function continuous at 1? It is. This is the absolute value function right here, isn't it? All right, then look at the next question.
Wait, why do you only have f?
Is that it? There's a 1f. Does the derivative exist for f of negative x? All right, so now think about it. What is f of negative x going to be? Isn't it like the absolute value? All right, so at x equals 2, does the derivative exist? Let's look at the absolute value, the one we just did, 1b. Let's look at 1b. Where did it go? 1b. At x equals 2, does the derivative exist? Yeah, the derivative is 0. That's not that important a point, is it? How about here? At x equals 1, does the derivative exist? No, why not? It's a corner. Okay? So that's the kind of discussion that you want to make. Remember, in this class, what have we done all year long? We gnaw at the problem. So we're talking, in this case, we're talking about a graphical approach, but then we're going to talk about a wordy solution. We're going to write in sentences what continuity means. We're going to write in sentences what differentiability means, right? Okay, there's no analysis here. There's no numerical stuff here. It's just graphical and verbal, really. Okay. All right, so we basically covered that whole question, right? Is that it? I think that's it. All right. So, all right, let's skip to 3. Are you ready? Write an expression for h, which is f over g. All right, so f is x to the 4th minus 4x squared, and g is x cubed minus x. So let's define those and graph h, which is f over g, the quotient. And then we can talk about, are there horizontal, vertical, and slant asymptotes? Why? Look at the graph and do some analysis. What's the domain? What does the graph look like? What's the symmetry of the graph? And that's it. Okay. This is really all preCalculus, this stuff. All right, so let's graph this thing. How are you going to do it? Number 3 is x to the 4th minus 4x squared. Okay, here we go. So here's number 3. All right, f of x is x to the 4th. Whoops, move this up a little bit. X to the 4th minus, what was it? 4 times, remember you have to say times when we mean it, x squared. And then g of x is, let's see, x cubed minus x. X cubed minus x. And h of x is the quotient of f over g. And let's plot that. Plot h. All right, so what do you notice in this graph? At x equals 1, what's going on? A vertical asymptote. Why? how do you usually find vertical asymptotes? The zeros of the denominator, right? Where it's undefined, where g is 0. When is g 0? Can you factorize? Factor out x, and then you get x squared minus 1. Factor that as x plus 1, x minus 1. So you have a 0 at 0, you have a 0 at 1, you have a 0 at negative 1. Why do you have a vertical asymptote at 1 and not at 0? Jason. He's doing the dance? Okay. Yeah. All right, why is there a vertical asymptote at 1, a 0 for g, at negative 1, a 0 for g, but not at 0, which is also a 0 for g? Because look at the factors of the numerator. Factor out.
Wait, that's also speeding up.
Factor out x squared. What's left? X squared minus 1, which also has the same zeros. But notice that the x that you factor out here cancels with one of the x squareds over here. So that when one of the factors that give you 0 in the denominator factors out, you get a whole. Why don't you see the whole? Because Sage is evil.
Can we do simplify?
Yeah, Sage doesn't do it. Yeah.
Can we do simplify?
Yeah, I don't think it'll graph it though. Right, so if you want, look at this. What if you factor f? Wait, f. Didn't we say it was x squared times x minus 2, x plus 2? And what if you factor g? Wasn't it take out x and to get x minus 2, x minus 1, x plus 1, right? So you have a vertical asymptote here, you have a vertical asymptote here. You don't have a vertical asymptote here. Why? Because it cancels out with that. Is that plotting f, g? All right, who's stuck? Coming around. Okay. Let's see.
Wait, but then how are we on number 3?
We're doing the odds. So these are the pre-tests. We're always odd questions. I don't know if you know that.
That's
X plus 1 is 4x squared. That's right. X minus x. That's right. X plus 2. That's right. I don't see an error. Sometimes it just needs a connection to the surface. So save it. Open it up again. See if it's okay. That's not it. F is G is H is. Open, close, open, close. All right, say this and take it from there tomorrow. All right, we're going to have to start printing some stuff tomorrow, too, for some homework checks. You guys need homework checks? We could do this for homework checks. All right? Don't forget your textbooks tomorrow if you didn't bring them in yet. I need your textbooks. My Kingdom for a textbook. All right, we'll continue this tomorrow. Yeah.
I'm not going to be here tomorrow
Okay.
because I'm going to be, I have my college orientation really early. So, are we going to print everything on Monday? Yeah. Okay. Are we doing any more, like, work? Like, am I going to be missing another worksheet?
Another worksheet?
Like on Sage?
Yeah.
So, I'll just come when to do it.
You can just see what we did online, and you can just do the one. When you're here, just do the one. It's just classwork.
Okay.
It's okay. Yeah, you don't have to do
Because
it.
I know I need it for homework.
Yeah, so, well, you can do the ones when you're here. You have 2 of them by now, right?
I have
You
3,
did. Yeah, so we'll print them out.
Okay.
All right. And goodbye, YouTube.